With the release of FEMAP version 2021.2, FEMAP extends its support for Nastran with the creation and editing of CBUSH1D spring and damper elements. The CBUSH1D element is a one-dimensional spring damper element. The property used for these elements is a PBUSH1D. You define this property using stiffness and damping coefficient values. Nonlinear spring dampers can be defined using a table with a versus time function or with equations. These options define a nonlinear spring. Damper, shock absorber, or a generalized spring damper. A CBUSH1D element x-axis orientation is defined by the direction from the start and end nodes. For a CBUSH1D element, equations can be used to define nonlinear force and damping behaviors. You create and edit these equations using the design equation simulation entity. This creates a Nastran D-Quantum card. To create design equations, use the Model Simulation Entities Design Equation command, or in the Model Info pane, right-click the Simulation Entities Design Equation object. Clicking the new Design Equation icon displays a formatted equation for the equation type selected in the Define Nonlinear 1D Spring Damper dialog box. In this example, we have two one-dimensional spring damper elements that are loaded in compression and tension using a Simcenter Nastran's multi-step nonlinear solution 401 transient analysis. The first 1D element is a linear spring damper with a stiffness of 10,000 pounds force per inch and a 0.02 damping coefficient. The second CBUSH1D element is a nonlinear spring damper using a function to define its compression stiffness. In this case, the compression stiffness is higher than its tension stiffness, as shown in the function dialog box. In FEMAP's charting pane, you can see the CBUSH1D's axial forces versus its axial displacements. Finally, to create a one-dimensional nonlinear spring using an equation, create or edit a new one-dimensional spring damper property, click the Nonlinear Frequency button, select the type of nonlinear spring damper, set the type to equation, and then click the new Design Equation icon. This opens the new Design Equation dialog box where you enter the equation. Equations then can be edited using the Equation Editor command or in the Model Info pane. To conclude, this enhancement to FEMAP increases productivity for those models that use one-dimensional springs and dampers by eliminating the need to manually edit a Nastran deck.